is so much to talk about as usual. Like, I don't know how we're going to get through all of this. It's a good job that I'm still on a massive high from my CERN trip this week. Well done to all of you who guessed right that that's where I was going. There will be videos coming very soon from that trip, which I am really excited about. But before that, we should get into recapping what's happened in space news this month, including the fact that we think the solar system might have formed differently, and another fast radio burst that's put the cat amongst the pigeons a little bit with theories of explaining what they are. All the timestamps are in the description if you want to skip ahead. But first, let's start by looking up at what we can see in the night sky in the coming month. So in the last week of February, from sort of like the 24th of Feb onwards, the moon is going to be coming out of its new moon phase, and it's going to look like, well, a toenail is what I like to say that it looks like when it comes out of that phase. And essentially what it'll be doing is setting later and later each night. It's going to be really close to Venus in the last week of February. So on the 24th, it's going to be below Venus, and by the 27th, it will have moved above Venus. Look to the west after sunset to try and spot this. I know that there's going to be so many pictures sent my way of the super bright Venus with the beautiful toenail moon next to it, and I can't wait to see them all. As we get into March and closer to the equinox, where you have equal day and equal night due to the Earth's axis tilt that causes our seasons, we need to start thinking about spotting the zodiacal light in the sky. So if you remember from a previous video I did, the zodiacal light is a glow in the night sky off the dust that's in our solar system plane. So this is what Brian May, the guitarist of Queen, did his astrophysics thesis on, and I did a big recap of that in a previous video, so check that out if you're interested. But now is around about the right time to spot it, because at the equinox, the plane of the solar system is sort of perpendicular to the horizon, so it makes it a lot easier to spot. Now, you are going to need a very dark sky to be able to spot this. So if you're a city dweller, I'm sorry, but you've got no chance. You need a very rural sky, and preferably one without a moon. So this is why the 10th of March is actually the best chance for you to be able to spot this if you're in the northern hemisphere. Because the 10th of March is the closest time we can get to the equinox, and in the evening sky just after sunset, when this is going to be visible sort of between like an hour and a half to 2 hours after sunset, we're not going to have the moon in the sky at that time. It won't have risen yet. In the southern hemisphere, however, instead of looking for it after sunset, you should look for it before sunrise. Again, sort of 2 hours to an hour and a half before sunrise, but look to the east, not the west. And again, what you'll want is a morning sky without the moon near the equinox. So you'd probably actually have to wait till more like the 23rd of March to be able to spot this. So sorry, you have to wait a little bit longer, but hopefully anybody who has access to a very dark rural sky at around March time, around the equinox, you should have a pretty good chance of spotting it. On the 15th of March, we have a quarter moon in the east just before sunrise, and it's going to be very near 3 planets: Jupiter, Mars, and Saturn. They're all going to be clustered quite tightly together in a very similar place in the night sky. And the side of the moon that's actually lit up will be the direction you can look to find the planets along the line in the sky that the sun takes, the planet takes, the plane of the solar system that we call the ecliptic, that goes through all the zodiac constellations. Now, if you look for that about an hour before sunrise, which is actually going to be pretty early in March because the clocks won't have gone forward, at least in the UK by this time. I think they've gone forward in the US by that time, but sunrise in the UK is still at 6 o'clock then, so you're gonna have to be looking around about 5 to be able to spot this. As it gets closer to sunrise and to dawn though, Mercury should also pop up above the horizon. You will need a very low horizon to be able to spot that, nothing in the way. And as Mercury rises, it might be a little bit too bright, the sky, to then be able to spot Saturn and Mars, which aren't as bright as, say, Jupiter and Mercury, very close to the sun. So you'd probably struggle at seeing all 4 planets at the same time in the sky. But if you get up early enough and you can sort of see the transition of the sky lightening as the dawn comes, you should be able to spot all 4 of them if you've got a nice clear horizon to do that. All right, that's enough for looking up. Let's recap all the space news that's happened in the past month. All right, first up, we need like a mission recap this month because so much has happened. First of all, NASA's Spitzer space telescope was retired on January 31st after 16 years of service. It was only designed to last 2.5 years, and with some clever engineering, folks at NASA managed to make it last much longer than that. This really was the end of an era. This was NASA's infrared telescope. We need infrared telescopes to be able to see through the dust in our galaxy. So Spitzer was used to literally see to the center of the Milky Way. It was used to see into star-forming regions that are shrouded by dust. And it was also used to detect exoplanets, most famously the 7-planet system of TRAPPIST-1. And infrared observations is not something we can do from the ground. We need space telescopes to see this because unfortunately our atmosphere absorbs infrared, and so astronomers are now clamoring for a new infrared telescope, and that should come with the launch of the James Webb Space Telescope, which is scheduled for March 2021, and that is still the official word from NASA. But I'm hearing a fair few rumors from people who work on the mission that that could be put back to July 2021, which is another delay that the James Webb Space Telescope does not need. We did see the launch of ESA's Solar Orbiter probe this month, though, on February 9th from Cape Canaveral in Florida. And this is a really exciting mission to study the sun. Now, it won't get into what's called operational orbit for about 2 years. It'll take 2 years to get there. But when it does, it's actually going to be in orbit around the poles of our sun, which is a really interesting region that we've not really been able to study before. It'll combine with NASA's Parker Solar Probe to cover lots of different areas of the sun simultaneously so that we can learn more about how the sun works and especially its mysterious magnetic field. Speaking of the sun, whilst we're waiting for those solar probes to make it into orbit around the sun, the Daniel K. Inouye Solar Telescope on Haleakala, Maui took its first ever image this month of the surface of the sun. It took a fair few and made a little movie of it. And what you can see are these incredible, what we call solar cells on the sun, which you can kind of think of sort of like plasma convection cells, where you've got lots of heat rising from the interior of the sun, cooling and falling back down again. And what's wonderful is it almost looks like the surface of the sun is bubbling, and each of those bubbles is about the size of France. And this is the most detailed picture of the sun that we've ever managed to take. So I'm really excited to see what will come from that telescope on the ground in Hawaii, and how that's going to combine with the Parker Solar Probe and ESA's Solar Orbiter in order for us to be able to sort of figure out the sun in the most unprecedented detail in the future. And whilst we're here looking at pretty pictures, anyone see that picture that China released from the surface of the moon taken by its Chang'e 4 mission this month? I don't think I'll ever get tired of looking at pictures of the moon. It's just so eerie and alien-like, so much more alien than, say, pictures of the surface of Mars, because Mars still has an atmosphere and the rock is sort of similar to what we see on Earth in desert climes anyway, whereas the moon with no atmosphere and this really barren grey rock just looks so alien all the time to me, and I could just stare at this image all day. Now we're moving out of the era of individual countries, government-funded space agencies launching missions into space now, and we're moving into the commercial era of space. And with it, we've had the launch of the beginnings of SpaceX's Starlink mega constellation of satellites. This is their goal to provide internet for the global population across the world, which is a fantastic goal to strive for. But currently there are 8,000 satellites in orbit around Earth, give or take a few hundred. Anything from sort of weather satellites, TV satellites, communication, military, etc. Some space junk as well. And with even those 8,000 satellites, if you're at an observatory, a professional observatory with these huge big telescopes, you're pretty much guaranteed that at some point in the night, one of the images you're taking of some tiny, tiny patch of sky that's, say, less than 1% of the size of the full moon, you are going to have a satellite that streaks across your image. And you just have to sort of hope and keep your fingers crossed that that satellite trail won't go over the very thing that you're trying to observe. Now, if that thing doesn't really change, then okay, you could do that observation again. But say you're an astronomer who's very interested in the variability of stars or black holes or X-ray binaries or some exotic object that varies on very small timescales, maybe even exoplanets as well, then that satellite trail could completely ruin that observation. So it's a big deal. And sometimes you just kind of have to say, okay, well, it was sod's law that the satellite went over at that time. But there's only 8,000 or so it can kind of be mitigated, even though you're guaranteed at least one a night. Starlink are going to take that from 8,000 satellites in orbit to 48,000 satellites. Compare that with the 9,000 stars that are visible to the naked eye from the darkest region of the planet, where you've got a dark sky site with no light pollution. You're vastly going to outnumber the number of visible stars that there are. So that raises two problems for astronomers. Number one, just the rights of the public, the general global population, to have their night sky unspoiled by satellite streaks that you will be able to see at nighttime. Then you've also got the impact to professional observatories, because the majority of astronomical research is done from ground-based observatories. You need the ground-based observatories to conduct surveys of the sky to find the objects that you then want to study in more detail with space telescopes. It is far too expensive to do surveys in space. It's also not really practical either. And if you think about the brand new observatories that are currently being built, yes, okay, you've got the James Webb Space Telescope going up soon, but then the majority are ground-based. You've got the European Extremely Large Telescope, you've got the 30-meter telescope, you've then got the Large Synoptic Sky Survey Telescope, recently renamed the Vera Rubin Observatory. They're all these massive, big, ground-based telescopes that are going to be looking at the sky night after night after night and really suffering from these satellite trails. So astronomers have opened the conversation with SpaceX. There was a paper published this month outlining these concerns of how ground-based astronomy is pivotal to professional astronomy and our understanding of the universe, how so many leaps forward in our understanding have come from ground-based observatories, and laying out, how many satellites would be in orbit, how bright they would be in comparison to the rest of stars in the night sky, and laying it out very, very clearly to both SpaceX and the public as well. In addition, there was a day's conference between SpaceX, the Royal Astronomical Society here in the UK, and the American Astronomical Society in the US, trying to have this open, constructive conversation between them to try and mitigate this problem before it's too late to do anything. Especially since that happened at the beginning of February, we've had 34 more new satellites put up, this time by OneWeb, who are also going to have one of these mega constellations of 650 or so satellites. So it's not like SpaceX are the only ones trying to do this. I've spoken to a couple of different colleagues that were there on the day. Unfortunately, I couldn't make that day's conference, which I was gutted about. But I think it all was a bit different matter of opinion on whether you thought that the conversation was constructive or not. And I'm really hoping that we can just come to a compromise that allows that goal to still be achieved of providing the world with free internet wherever you are globally, because that is an incredible thing to strive for. But at the same time, not halting the progress of science and our understanding of the universe, and also not robbing the public like yourselves of their right to an unblemished night sky. Now, on to the solar system. And if we wind back 4.5 billion years until the beginning of the solar system, and we think about how planets, asteroids, comets, objects in the solar system formed, the leading hypothesis for the past couple of decades is that lots of little clumps of rock and matter started clumping together, and then they would collide quite violently, and that would probably melt a lot of the rocks that it could form into a sort of roughly spherical shape, and lots of collisions like that would happen until you built up bigger and bigger bodies. That was called the hierarchical formation model, and the crucial thing there was that the collisions were violent enough to be able to reshape the rock. But 15 years ago, a new theory emerged from simulations that showed that perhaps those collisions weren't as violent as we thought, and that actually they were much more gentle, sort of a bumping and a meeting of little planetesimals, little clumps of rock in the early solar system. And that was called the pebble accretion model. Obviously, simulations are great. They can tell us a lot if we plug in all the laws of physics that we know. But obviously, if we're making an assumption or we're missing something, then perhaps, they couldn't be giving us something that's realistic. So how to test which of those models, the pebble accretion or the hierarchical accretion model, were correct is quite difficult. You have to be able to probe some of the leftover relics from that very early days of the solar system. Now, thankfully, they exist still out in the Kuiper belt beyond the orbit of Pluto. We have lots of those little planetesimal chunks of rock that are still floating about in the forms of sort of lumps of asteroids. And if you remember, the New Horizons spacecraft, after it went past Pluto, did a flyby of an object in the Kuiper belt called Ultima Thule back on New Year's Eve 2018. And we got the images through on New Year's Day 2019 of this asteroid that looked a little bit like a snowman. It was quite appropriate for getting it back on New Year's Day in the middle of winter, but the Northern Hemisphere anyway. And the fact that it looked like a snowman puzzled everybody, because if you had a violent collision of two objects, you should not have retained that snowman shape. You should have completely obliterated the previous shapes of the two objects that came together to amalgamate and form a new one. And so a year later, the scientists on the New Horizons team have managed to analyze all of the data they got from that flyby, and they have published this month 3 papers explaining what they have found, all of which presents evidence that's in favor of this pebble accretion model. And so now we actually think that our understanding of how the solar system and other systems out in our galaxy and beyond in the rest of the universe have formed and come together in a very gentle process. And in fact, the scientist who was responsible for publishing this idea of the pebble accretion model 15 years ago, he was a PhD student at the time as well. So it was very almost brave to trust in his simulations that much and not think, oh, is it just a bug in the code that's causing these gentle collisions? He's now a professor, Professor Andres Johansson. And my favorite part about this story is that he posted a picture showing how he was celebrating this result from the New Horizons mission, sort of siding with his theory of how things were happening in the early solar system by having a pizza and Coke with his family. Now on to everybody's favorite unsolved mystery in astronomy right now, and that is fast radio bursts. So way back in the early days of the history of this channel, when I was still figuring out audio and focus on a tiny camera, very different to focusing on the giant CCDs that I'm used to on massive telescopes. I did a very blurry video on these fast radio bursts, but a lot of you liked it because it covered, what is our best understanding of these things now, which isn't a lot, to be honest. All we know is that they are very short millisecond bursts of radio waves that we detect from outer space, outside of our own galaxy even. And some of them we see once and that's it. And some of them repeat as well, which is strange because as soon as we started detecting these fast radio bursts in 2007, people thought they might have something to do with a big cataclysmic event like a supernova or a gamma ray burst, something that's this big one-off giant explosion of energy that you might get this very, very rapid burst of radio waves. But as soon as we then found a repeating fast radio burst where you got these millisecond pulses on repeat, that put paid to that idea of it being this one-off big explosion event like a supernova. These repeating sources, though, are completely random. There's no rhyme or reason to them. There's no pattern. There's no periodicity. You can't predict when they will arrive next. They are completely random. So since 2007, we now have a handful of these fast radio bursts, but we're getting more and more with the switch on of this experiment Chang'e in Canada, which is a radio telescope not like most other radio telescopes. You can't actually turn it and point it at the source that you want to. It just sort of scans the part of the sky that is currently over the top of it. So in a sense, it's like always listening. So one of the sources that the Chang'e experiment announced last year and was able to triangulate back to a galaxy that was quite nearby, 500 million light years away, nearby-ish in astronomers' timescales, a beautiful, quite large spiral galaxy. They've actually found, when they looked at all the archive data that they have from September 2018 to October 2019, that it actually had some periodicity to it. It repeated every 16 days or so, except the fact that you would find bursts that came, again, at this random, unpredictable pattern in a 4-day chunk, and then you'd go 12 days without anything, and then you'd have another 4-day chunk where, again, it would be completely unpredictable. You could detect lots and lots of bursts in that 4-day period, or you could detect one, or you could detect none, and then you'd have another 12-day period of quietness before you'd have another 4 days where it would be completely random again, but you would detect some of these fast radio bursts. And that's really put the cat amongst the pigeons here, because yes, okay, it's still random and chaotic like the ones that we've had before that aren't really predictable, but there's this overarching 16-day period to it that people aren't quite sure how to explain. Now, some people have suggested that perhaps that whatever object does give off fast radio bursts is perhaps in orbit around another object, and perhaps when the other object blocks it is that 12-day period where we don't see anything. Now, 16-day orbit is obviously a very short orbit, so that would be a very energetic system, so that might give us some clues as to what could have formed these fast radio bursts and could have been producing these fast radio bursts. Then people have been suggesting perhaps that whatever object's producing these fast radio bursts is rotating, and we're seeing them sort of lighthouse style as something like the pole of the object passes across where Earth is in the sky, and so for that point in time we get these sporadic fast radio bursts coming from it. But again, that's putting the periodicity of this 16-day down to either orbits or rotation. It's not actually to do with the thing that's producing the fast radio bursts. And unfortunately, it doesn't really necessarily give us any more clues as to what it could be, whether it could be something to do with a magnetar, this sort of neutron stars with huge magnetic fields. I mean, neutron stars or black holes, we don't really have any idea still. But I think it's still interesting to think about the fact that these objects producing these fast radio bursts could be in normal orbits around other objects, just like we see other things in our universe. That's it for Night Sky News this month. Keep a lookout for the next episode of the podcast I do with the Royal Astronomical Society coming out next week. I will link it in a community post when it does come out for you to hear it, because I know a lot of you like podcasts as well as YouTube for listening on the go or on the commute. Until next time, where I hopefully maybe have a CERN video for you, leave me a comment below and let me know if you do spot any of the things I talked about in the sky this month. Maybe send me a picture on Twitter or Instagram as well, because as always, I'd love to see it. Telescope has just started taking images on Haleakala in Maui. I wanted to say Moana then, but I started saying Maui. The Daniel K. Inouye Solar Telescope on Haleakala, Malawi. Not Malawi, Maui. It's funny how you say FRB rather than like how NASA is, you say it as a word, like rather than like the NASA. It would be fun to like FRBs were actually called FERBs. If I started calling them FERBs, would people know what I meant? Probably not. Put that dream to bed. Too. Uh-huh. I mean, everyone knew that was coming, right? So...